What's up, Fungal Associates? Welcome to Completely Arbortrary, Season X. It's the show about trees.
Oh, he panicked. He got too intense.
I had to switch back to my normal character. It's the podcast about trees and other related topics. I'm one of your hosts. My name is Alex Crowson. Of course, over there on the big green couch, we have Casey Clapp.
This is me, normal character. Alex, I have an existential question for you.
Hit me.
If you are playing your normal character,
Wow.
Is that a character or is that just you?
That's a character. That's normal character.
So normal character
Alex.
is like you're the species variety. You're the null hypothesis.
It's called masking, my friend. Even when I'm myself, I am someone else.
No.
Like Patrick Bateman.
Who are you? Wow. Okay.
I'm nothing like Patrick Bateman.
Who's Patrick Bateman?
American Psycho.
Oh, I'm thinking Jason Bateman.
Yes,
and
of
I'm
course.
Like, not the guy I'm thinking of.
Not psychotic. However, he is American.
He has been known to do more intense thriller type of things more recently.
That's true. He's getting into that. Ozark.
I heard Ozark is great.
I've heard Ozark is great.
I like Jason Bateman quite a bit. I know him from his best role, which is from Arrested Development.
The best
it's just
television
so good.
comedy ever made.
Yep. Say no more.
Yeah. Casey, as much as I would fucking love it, this show is not about TV.
Talk about TV. You know what? That's going to be season 11.
Oh, hell yeah.
It's going to be completely arbitrary, but it's going to be flipped entirely.
Oh, my God.
I'm going to be the host. You're going to tell me about some show.
I just had this like elated feeling, and I was like, wait, this is how Casey feels about this show.
Yeah.
Like this elation of being able to talk about your favorite topic every week. Casey, but before we get into this week's tree, I wanted to share some exciting news.
Ooh, tell me.
I will just say to people, keep your eye out for a new podcast from me. It's my friend Robin.
Yeah.
And her brother.
Yes.
Robin is a cheesemonger.
Okay.
Her brother's a world-renowned sommelier. And they want to start a completely arbitrary style podcast where they talk about cheese and wine.
That I am so into this, but only as let me have some of that cheese and wine, and then tell me about it.
Oh, you'll learn a thing or two.
Yeah, I better.
But yeah, I'm their new producer.
Congratulations!
And, thank you. I'm very excited.
Okay,
and I'll be promoting the fuck out of it when it comes out. So
yeah, we're going to be putting it on this show every single time.
Absolutely.
Okay, when do we expect it? Give us the details.
No details.
Okay, great. Everyone,
not yet, at least.
Mark your calendars like tomorrow
with invisible ink,
and just say look forward to.
Yes, more look forward to. Well, Casey, I look forward to talking about the blue ash.
Wow, because that's what we're talking about today.
And we got to do that after a quick break, but we will be right back with the blue ash here on Completely Arbortrary. Welcome back to Completely Arbortrary. Today we're talking blue ash.
That's right, we are.
Casey.
Alex.
I know nothing about this tree. I've never heard of it.
Many people haven't.
Let's imagine as we do every episode.
Okay.
It sounds like a southern tree to me, so I'm going to say we're in the American South.
Okay.
Maybe Tennessee.
All right. Yeah.
And we come across some blue ash. Casey, let's ID this tree.
I am happy you at least said Tennessee because I believe that is, I'm going to say one of the more southern places you can actually find this tree.
Okay.
But for the most part, it actually is further north. Like its bread and butter is essentially like Ohio, northern central Illinois, and then Missouri.
Little Midwestern tree.
Yeah, it's a central northern-ish Midwestern tree.
I like that.
Which really opens us up to the big question that I think everybody has had on their mind for years now. Is Ohio a part of the Midwest? Okay, boy. I'm ready to talk about the blue ash.
Let's do it, Case.
So the blue ash is a species called Fraxinus quadrangulata.
Wow.
I love the name. It is one of my favorite. Yes, exactly.
4 sides.
Yeah, now here is, just let's skip straight to it. It's all about the twig.
No kidding.
It's the twig.
Oh, let me guess.
Okay.
When you roll it in your fingers, it's like kind of square.
It's very square.
Okay.
Yes. So much so that where if you take a photo of it, you can kind of see. But if you are to like zoom in closely, like you said, roll in your fingers, it's very much like clunk, 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 clunk.
Wild.
Where it is so very square. And in fact, most of the time on the little edges where the corners of the square would be, there's this little tiny like just a little ridge right there.
Wow.
So often it's extremely obvious.
Cool.
Sometimes it's a little bit less, clear, but it's there.
I see them.
Yeah. Do you have a twig?
Landscapeplants.org and state.edu
Beautiful.
calls them corky wings.
Yeah, and if you look at the twigs on that particular thing, you can see there's like this little tiny corky ridge, like so small. It's like it's kind of hard to see unless you're zoomed really close.
It looks like a little roadway going down the side of the stem.
It's beautiful.
That's
it's
really
so
cool.
lovely.
I don't think I've ever seen anything like that.
There are very few. I think the red alder has like triangular kind of ridge things. Some needles are different shapes like that, but for the most part, twigs are just kind of generally round.
Yeah.
So having this particular kind of wing is unique. And a few other species have like corky ridges or wings, but none are so perfectly, geometric.
Yeah. Great.
So that's, of course,
very cool.
The big thing that we're looking at. That's why the scientific name is what it is. But then if you go and you look at the buds on that little twig, all of the buds, they are oppositely arranged because it's an ash. It's an Oleaceae. That's the olive family.
Oleaceae.
And everything is opposite in that realm. And they are like, I don't know, covered in a little bit of hair. They're a little bit gray-brownish, and they're just like tomentose. So they're very like short, tiny, dense hairs just kind of covering the whole thing. They just look like they got a nice 5 o'clock shadow kind of thing.
Okay.
Lovely little guys. And of course, on the ends of the twigs, you're going to have leaves. This is an ash tree, which I should note before I say, and like all ashes, many ashes do not. No, a few of them don't have compound leaves, but most ashes, they have pinnately compound leaves.
Okay.
So you're ever looking at an ash tree, it's going to be opposite, and it's going to be pinnately compound.
This is a good looking pinnate compound leaf.
Real good. It's got 5 to 11 leaflets. It's about 14 inches long. It's 35 centimeters if you're nasty. And covered in hairs.
Cute.
All the little petioles covered in hair. All those little teeny tiny hairs on the midrib, the rachis. Everything about the tree is kind of like so casually kind of hairy.
Kind of velvet.
Velvety,
Is this the
yes.
sort of thing that if you touch it, you'll be like, oh, the velvety leaf. Like you'll definitely feel it.
No, it's not quite that intense.
Okay,
It's only on the midrib and the rachis on the bottom of the leaf, really, that you're going to see it. Maybe a little bit onto the actual leaf blade.
Gotcha.
But there's an ash down in Arizona called the velvet ash.
Oh.
It's much more like that. And here in the Great Pacific Northwest, our Oregon ash also has a very, very fuzzy, velvety everything.
Gosh, I just love that. If I were a tree, I would definitely have tomentose.
Oh, yeah. I mean, it's classy, I think.
And let me just clear something up for people.
Yeah, okay, yeah.
You'll hear the word pubescence, and you'll hear the word tomentose.
Yeah.
And you'll be like, are they using them interchangeably? I can't really tell. Here's how I always remember it. And I think you've told me this is good.
Okay.
That pubescence is like hair, like
Yeah.
the hair on your head.
Yeah.
Or on your arm.
Or, between your crotch.
Sure.
Or in your crotch, not between your crotch. Whoa!
Between my crotch and what?
And,
Tomentose is like fur.
yes.
Like a dog's fur, thicker.
Way more thicker. Yeah.
I guess that's the big thing, thicker.
Yeah, pretty much. Yeah. There's more hairs per, unit area kind of thing. Way more dense and usually much shorter. So that is what those twigs look like. It's what the leaves look like. They're pointed leaflets. Like I said, it's about 5 to 11 leaflets. And as you see the whole tree, you step away from these twigs and leaves, you'll notice it's kind of just a nice big round tree, 50 to 70 feet tall. It's not a giant tree. It's not a small tree. It's just like, there's an ash. Look at that ash.
Yeah.
Hot ash.
Is it true that this tree are the rumors true? Does this tree grow in a very like upright the Y of YMCA kind of appearance?
It kind of does, but it's not really, I don't know. The form does not jump out at me in a way that I'm like unique. I'm like, it's just another tree that grows up and grows out.
It does just look like a tree in the park.
It is. It's a very generic tree.
There's some trees over there.
Yeah.
Blue ash.
It's probably blue ash. Yeah. Sorry. Yeah, that's pretty much it.
Okay.
Kind of blows your mind, doesn't it? It's like
I can respect it.
It's just a normie tree.
It seems like a blue collar tree.
It is a blue collar ash.
Just like it goes to its union job and is a tree all day.
Comes back.
Yeah.
Goes to sleep at night, wakes up in the day, does it again.
Yeah, nothing fancy. Got an alcohol problem.
Nothing fancy. Well, it beats its saplings every now and then, but
Oh boy.
They gotta learn a thing or two.
Are we classist? No, because we are also working class.
Oh, I beat all of my saplings. Duh. No, I treat all my saplings with respect. So here is the other thing that is usually pretty like telltale for ashes is that they generally have this like cross-hatched bark where it looks like there's flat top ridges that interweave. So they kind of create this diamond pattern effect.
Cool.
Now, the thing is, though, for the blue ash, they really like do that to a certain extent. Like it looks like, oh, there it's developing as it gets older. Oh, and then it kind of breaks down. And it kind of becomes this semi-flaky, semi-broken up kind of bark that doesn't maintain the crosshatch kind of pattern like a green ash or an American white ash. Like they just really stick with it their whole lives. But the blue ash, it kind of, as it gets larger, kind of falls apart. It kind of looks more like it just becomes densely rough and like kind of uniformly patterned, but not insanely obviously crosshatched.
Interesting.
Yeah, it's really beautiful. I like it quite a bit.
I like the texture of the bark. It's cool.
It is really nice. It's a nice tree. It's got a nice little bit going on. Now, here's the thing. We have like several different species of ash that are native to North America. Give or take 16 to 20 is by my count. And that's depending on where you draw the line, because some of these go south down into Mexico and Central America. Otherwise, in the southeast and the southwest, here we have one species in the west, multiple in the northeast, and the central Midwest or whatever you call it, Ohio. About 16 or 20 species, quite a few.
That seems, I don't know. That seems low.
Well,
just for how much land mass that is.
Yeah, that's fair.
Only 16 to 20 ashes.
Yeah, well, that's
Fraxinus.
That's true. And on top of it, this species, this whole genus rather, is likely to have developed here in North America.
Oh, cool.
So this is a homegrown little group here, which is, similar to our pines, firs, spruces, probably all started somewhere here in the southwest, somewhere in North America here.
Cool.
So it's one of those, been here for a long time, and I don't know why. They all, like all the big popular ones that are like very, very common, they're all named after colors. There's the blue ash, the black ash, the white ash, the green ash. And then all the others like other ashes.
Wow.
I don't know why, but I
like that.
All those, super common. I would not be surprised if there is a red ash somewhere out there. We have our Oregon ash is the Oregon white ash. Then there's the American white ash.
Wild.
There's no good reason for it.
Here's my theory. Marketing.
Yeah. Okay. What do you mean?
I won't be taking questions.
Oh, shit. Okay. I'm going to have to send this into your agent.
Everybody can remember ask the nursery guy for red ash.
Yeah. Okay.
We can plant those on our road,
Okay.
Black ash. Great.
It's easy. It's obvious. Okay.
Yeah. It's not like Clark's Woodland Fragrance Nutcracker.
That is true. But I think what I love about it is that because it ends with ash, it just opens itself up to innuendo.
Itself up.
It just opens itself up. Man, that white ash always opens itself up, doesn't it? I sure do. Yeah, so I just love being like, ooh, yeah, and just like add the name ash afterwards, and you're like, you maybe don't say that at a conference. That's
damn, look at that ash.
It's just so funny to me.
That is fun.
Now, I will say,
wow.
Of all the colors associated with ash trees, the blue ash is the one that actually has some relevance.
Okay.
Because the bark is used often for a dye, where if you expose the inner bark, it'll turn blue.
This is shocking.
Yes.
Because I was convinced it was some sort of bloom situation.
Oh, where it looked blue on the outside of the leaves or something.
Yeah, what am I thinking of?
Like
stomatal bloom.
Totally, yeah.
I feel like that's usually what makes something, quote, blue.
Yes, like the blue spruce and things like that. Yeah. Blue palo verde.
So you expose, nice pronunciation.
Thank you.
So fast. So you expose the inner bark to oxygen, and it turns blue.
It starts to turn blue, and if you take it in, you put it under water and you macerate it and like really just jam and rub it off, then it'll turn the water blue, and you can make it into a dye.
Crazy.
Yeah. So this is the one. I don't think you can do that with green ash or white ash or black ash.
Yeah.
I think they're just other names for other species for one reason or another.
Interesting.
Now, here is the real fun thing that I really want to bring us up.
It gets more fun?
It gets more fun.
Hit me.
Because this tree, most likely, as I noted, developed right here in the great North American continent, and it has spread out through the rest of the world. There's somewhere between 40 and 43 species of ash across the world.
Wow.
And a bunch of them went over into Europe and Asia and created a whole new group. I think there's like 5 subgenre in here, like little sections within it.
Okay.
And the blue ash is one of the most ancient. It's been around for a really long time. Most of the others have gone away from it. In fact, the flowers, which we didn't talk about, are the 2-petal variety. And this is a monoecious. Actually, it's not even monoecious. Its flowers are perfect. They are
cool.
bisexual flowers. So they will have male and female parts, and they'll create these little paddle-like samaras, single samaras, which is the ash calling sign. And this whole group, right, developed right here. Went across the world, changed. Became different.
Of course.
Some started to do 4 petals. Some got rid of their petals altogether. Some decided, you know what? I'm going to have a bunch of petals and I'm going to make them big and beautiful. And I'm going to be like a flowering tree. And others are like, meh, I'm cool. I'm just going to like use the parts that I need and move on.
They got brand new on us, Case.
They did. Everybody changed.
2 petals.
Yeah.
That sounds very ancient.
Yes, it does kind of. I don't think it maybe 45 million years old, the whole genre, the whole genus.
I wouldn't know if that's ancient or not.
It's like basically yesterday.
It's the blink of an eye, really.
It's a blink of an eye.
Well, my follow-up question.
Yes.
The other very ancient tree I know that has an interesting, perfect flower, the magnolia,
yes,
is pollinated by beetles. And I'm wondering if maybe the blue ash is pollinated by some alternative pollinator.
Honestly, most of it is wind pollinated.
Oh, that's not fun.
But not all of them. Like some of them, like the flowering ash, which is Fraxinus ornis, it's pollinated for sure by insects because it produces way big, more gaudy flowers.
Okay.
So it's constantly like getting other animals to come to it.
I have a question about that, by the way.
Okay, yeah, go for
I know
it.
I'm like on a tangent, on a tangent, on a tangent.
That's fair. That's okay.
But aren't all plants wind pollinated, really?
No. Some are precisely pollinated by insects.
So, okay.
Or bats or birds.
But if I blow on a flower,
Yeah.
some pollen's going to come out.
Yeah, for sure.
But if it just lands on another flower,
Yeah.
of the opposite sex or whatever, I don't know how that shit works.
The birds and the bees. Alex.
It's literally the birds and the bees. It won't pollinate because it needs to be like inserted or something by an insect. I guess I just don't know where you draw how you decide something is pollinated by insects or by wind, but probably kind of both, right?
Yeah, I think if wind happens to like take the pollen away, then it works. And they're like, great, whatever. I don't care how it happens.
Okay.
But some plants are so specialized where the pollen sacs, the actual stamens, they are not even accessible. They're not exposed to the wind.
Okay.
An insect has to go in and actively get the pollen on them in order to move it. And I'm sure some pollen's like a little heavier and a little lighter.
Oh, sure.
So some probably is very easily transferred on the winds.
Oh.
Others might be like, no, we're actually like not even able to be taken by the wind because we're just too heavy, so we don't go too far.
Okay.
But that's conjecture. I don't know that for sure.
That makes that answer makes sense to me.
Okay, cool.
That it's kind of like trapped in there. It's not just like out there. It's not a naked seed.
Exactly. They're like some like birches. They're like, yeah, we're just going to let the flowers just get pollinated by the wind. We're just going to throw out so much pollen.
Yeah.
So yeah, it's just kind of specialized methods to make sure that you're being as efficient as possible.
I gotcha. Thanks, Case.
You're welcome. Anytime.
Every once in a while, after 5 years, I'll be like, wait, why have I never thought of that?
Well, you're just now coming into your stride, in my opinion.
I guess so. I'm unlocking a new level.
Okay, so here's the thing. Being that this tree has developed here in North America, ironically, it has developed into a situation with a big change that happened in the last 24 years that has caused the trees that grew up here to basically be not, well, the term is naive.
Now, 24 years. Hold on.
Yeah.
Are you blaming 9/11?
So what happened is Osama bin Laden decided that this tree had it coming and introduced emerald ash borer.
Wow.
Okay, that's not the case. Turns out.
So 24 years ago,
Yes.
the emerald ash borer Oh, ash, yeah.
Yeah.
Was introduced to North America?
Exactly.
Tell
we
me
found
more.
it in southern, I think it was Detroit in Michigan is where we initially found it. And it's a species of insect that is, of course, emerald. It's a little green guy. And they lay their eggs. The females lay their eggs on the stem. Then the babies burrow themselves into the bark. Then they eat all of the cambium layer inside the bark, under the tree's skin, essentially, and they girdle it. Once the tree's girdled or they get their fill, they then burrow themselves out. They dig this D-shaped exit hole, very, very clearly a D-shaped hole. And then they fly off and they go find another tree. They don't fly very far. So they just like kind of bumble their way around till they find a new one, and then they start the process over again. So we've talked about this way back in 2021 with the green ash.
As if I remember any of that.
Oh, you remember because the name of our show was FLC. Was it FLC? No. Oh, it was Fuzzy Little Camel Toes. That's what it was. FLCT.
Wow.
That's the name of the episode. Because I was describing the buds
That's
of,
right.
of
As
the
fuzzy little camel
Yeah, I was
toes.
like, they look like fuzzy little camel toes. Yeah, and you were like, we got to make it the name, and I was very embarrassed, but we made it through.
Of course I remember that.
So we talked about how the green ash and other ashes in North America are highly, highly susceptible to the emerald ash borer.
Yeah, particularly so, right?
Particularly so.
Okay.
And the term that we use is kind of like they are evolutionarily naive, which I love as a term.
Wow.
It's I don't know, it has a lot of nuance to
I like
it, right?
that, yeah.
So basically what that means is that something changes, in this case an invasive species comes in, and these trees that have grown up without this insect at all, even anywhere close, and anything like it, none of this has ever affected them before.
Right.
When you bring in this new pathogen, this new insect, all of a sudden their naivete is that they have no defenses. They're like, oh, I've never had an insect burrow into me. Then when the insect burrows into them, they're like, oh, well, that's fun. Whatever.
Oh, I'm dead.
Yeah. Oh, and then exactly, and then they just kick the bucket, and it's kind of like the dodo, which is famously a dumb bird, right?
May I?
Dumb as a dodo, please.
The dodo couldn't feel fear. It never evolved to have fear because there were no natural predators on its home soil.
For millions upon millions upon millions of years.
Yeah. So
exactly.
the humans showed up, the ultimate predator, and clonked him on the head. And the other ones watching were like, whoa, what just happened?
Yeah.
Oh, well. And then they got clonked on the head until we killed them all.
Exactly. And it took us 100 years or less to just destroy them all.
Insane.
Actually, I think it's 50 years.
That's crazy.
It's as fast as we could actually get to the island. Same thing with the tortoises and a bunch of other things on that island, right? Mauritius.
Sure. You know what this is like, Casey?
Yeah.
It immediately reminded me of when the emerald ash borer lands on this naive tree. It's Sauron. When Frodo drops the ring, or when Frodo enters Mount Doom, or at some point at the very, very, very end, Sauron realizes what's going on.
Yeah,
and up until then, he had no idea that that anybody was in Mordor trying to take the ring to Mount Doom. And there's this great passage that talks about he didn't even fucking consider that as an option.
Yes.
And that's why it worked.
That is why it finally actually was a thing.
I love that fucking book.
It's so good.
God damn.
That's exactly what happened.
Yeah.
That's exactly what's happening. The trees, essentially, if we take this metaphor out, they have no idea that something is coming to kill them.
Wow.
And that's kind of the funny thing is that most trees, if you burrow into them, if something happens, they have this this trigger. They're like, ooh, something's up. I'm being attacked. And they respond.
Push out some sap.
Yes, totally.
Something like that, yeah.
They do something that changes their chemistry to make them a little bit less palatable. They add in some tannins or lignin into their cells to make them less palatable, make them less nutritious, even poisonous in some regards.
Wow, interesting. So, sending out pheromone signals to other trees.
Exactly.
I'm assuming the blue ash doesn't do that.
Well, see, this is the thing. Oh. It turns out that every other ash species in the Northeast, for certain, the Southeast, everywhere in the kind of eastern United States, because that's where emerald ash borer has gotten to, essentially started in Michigan, has expanded out through essentially all of the eastern United States.
Damn.
it has gotten into Colorado, and just in the last 2 years, we found it in Oregon, and now it's popping up in BC and one place in Washington, I think.
Wow.
So it's actively spreading, which we've been aware of and we've been expecting for a long time.
Okay.
But throughout all that, it has killed almost every single green ash, white ash, black ash, and every other species that it's come in contact with that's non-native, except for one species that we've planted called the Manchurian ash.
Oh.
That is the native co-evolved ash tree that the emerald ash borer originally started on.
In China?
Basically Mongolia, of Eastern Asia.
Wow.
So this Manchurian ash, it has grown up and co-evolved with the emerald ash borer. It's not effective. Some of them will die, but it's not like affected in a way that like an entire swath of forest of these trees are going to die. So that is the species over in Asia where this insect developed, right? Mm-hmm. But here in North America, there's one species that's native that is also apparently immune. It's the blue ash.
Wow, the blue ash is impervious. It is. What is the opposite of naive? Jaded.
Yeah, exactly. Yeah. The blue ash is sitting there smoking cigarettes and be like, you fucking come close to me, I'm going to burn you out.
Just
I've
waves
seen
them
your
away.
type before.
Yeah.
Yeah, it's lived its life. Yes.
Wow.
I don't know. Yeah, jaded might be reasonable because it's not naive at all. It knows, or apparently, rather than saying it knows, it just has the compounds that it reacts, whereas all these other species just don't react.
What is that compound?
This is kind of the interesting thing. So it's less of a compound and more kind of two different things that this tree does. So it does better at putting on callus wood once it gets attacked. So it kind of rebuilds and compartmentalizes off the places inside of the wood that get damaged.
Now, when would it know when it's being invaded? When the larvae
Oh yeah, say it with confidence, Alex.
burrow into the cambium?
Yes.
Okay.
Exactly.
Not when they're laid on the tree.
Yeah, precisely. At least then, probably yes. Okay. When it actually gets into the cambium, the living layers, then the tree registers something's going on.
Starts building callus wood.
Exactly. It does that.
Okay.
But also, apparently, it just has more cocktails in its cambium, in its vascular system, that make it so that the larva, once they get in, they kind of develop way more slowly, and most likely are just a little bit less fit. They just tend not to go in and go crazy and kill the whole tree, and the whole tree seems to be able to kind of take that level of attack and not die.
Interesting.
And not only not die, but it's like when you have 16% of the trees of white ash die within a couple years, 87% of blue ash survive.
Interesting.
So it's not even like, a little bit more, but they all still kind of get it. It's like, no, blue ash crushes it.
Yeah.
Every single other species, 100% dead.
87, you said?
Yeah, 87%.
Wow.
And this is just in one study where they basically said, we went back and 87% of the trees we looked at were still doing fine. Like their canopy's still full. When you go underneath and take off some of the bark, there's fewer and smaller galleries, which means that there are fewer larvae and the larvae don't get as big.
Galleries are sort of a trail that a bug makes inside a tree?
Exactly, correct. Okay, yeah. Thanks for asking.
Yeah, like an ant farm gallery.
Yes, precisely.
Okay, I've heard of that, yeah.
And then for the white ash, for the green ash, for the black ash, they are just riddled and the insects just go crazy.
Well, go ahead.
Well, apparently the insects, the actual mothers, there's this idea that mothers know best.
Yeah.
And the females, before they actually lay their eggs, they actually will choose a tree that is more likely to be successful. So they're like, ooh, this blue ash is not the one I want.
Whoa.
They already know that that's not going to be the good one. So likely, my guess is they can smell something that's going off the blue ash.
Totally.
So they move to a different one.
Wild.
Isn't that crazy?
That's crazy, before even getting into the tree.
Yeah. So the other ash trees, they all get completely destroyed. The blue ash seems to just be able to take it and fight against it a little bit, but also the insects are like, oh, this isn't worth our time, so they don't even try.
That's incredible.
Yeah.
Well, here's my big, looking to the future.
Please, yes, because this is the big question, right?
I'm sure, yeah. So, fucking 17% of white ash survive.
Yeah.
So 83% are dead. That's a lot of trees, I'm assuming.
Oh, yeah. Literally hundreds of millions of trees are dead right now in the
Hundreds
east.
of millions?
Hundreds of millions.
Okay,
the green ash, the American ash, they are so common. Like, they just grow like gangbusters everywhere. Like, I saw them all throughout Iowa when I was visiting. It's like, what are all these dead trees? And I was like, oh, those are ashes.
Dead. And we think, the tree people among us think, well, we got to replace them. Are they replacing them with blue ash?
It's very likely, yes. Now, really, I think most managers are just not planting any ash at all.
Just in case.
Exactly, because the insect will get into the blue ash and they will cause some damage, but the amount of mortality is much lower. But the trees will still kind of allow these insects to then leave and go find another tree. So they kind of become breeding grounds almost. Oh. Not in a way that's like, oh, there's millions coming from this one tree.
Okay.
But they're kind of like, we just kind of don't want any ashes around.
Yeah.
But if
they're
all
like
the other ashes are dying,
or whatever.
Exactly. Yeah. They don't die, so they become these havens for these insects to live in.
That makes sense. Bummer. Wow.
Yeah, but so here's the other thing. If we're looking into the future in an evolutionary sense, remember how we, like last week, we talked about one species that kind of grew up and went over the entire West, and as it got further away, it kind of speciated over time and changed its habits because of birds and other stuff, right?
Limber pine.
Exactly. Now, here we have a different kind of evolutionary pressure, where we have multiple different species with the same kind of overlap in terms of where they grow. But then if we get rid of, because of this agent that comes in, kills all of the green ash, Fraxinus pennsylvanica, all of the American white ash, Fraxinus americana, all of the black ash, Fraxinus nigra, they're all gone. But one species, still there, still kicking it. Now there's all these open niches, all these open places that a blue ash can put its new little roots.
Oh.
So now the blue ash will expand its way out.
Okay.
Conceivably. Who knows if it actually will.
This isn't currently happening yet?
Not as far as I can tell.
Okay.
But I don't know if anyone's actually studied it and said, has the blue ash been expanding its range? But if people have thought about it, they're like, this might be a possibility.
I think it's extremely clear what's happening here.
What do you think? What do you see?
The blue ash is a double agent.
Oh my God.
And invited the emerald ash borer.
It's the colors. It's the
oh my
colors.
gosh. Look to the colors.
Look to the colors, the blue and the green.
Yeah.
Yeah, honestly.
They're like, yes, we'll lose some blue ash, but it's good for it's an
good
investment in the future.
Exactly. So now the blue ash kills all the competition. Now it can grow out into the rest of the world, and now the emerald ash borer is like, oh yeah, but now we also got a buddy that we can just hang out and eat some of and then go away.
Wow, killing all competition and growing out into the world. Where have I heard this before, Casey?
I think it's in every capitalist society in the world.
It's an imperialist tree.
This is imperialist tree.
That's despicable. I now hate it.
Now you hate it.
It should have died with the rest.
Okay, we're going down the wrong path here, buddy.
Oh, sorry.
But here, this is like the evolutionary question, though. So if we are looking back, if we fast forward 5 million years, we look back on this moment.
Okay.
We're like, wow, something happened in these trees.
Yes.
We can basically say, well, it seems like there was this bunch of population, multiple different species. One agent came in and killed all of them except for one species. That species then expanded its range, and then it got so far away from itself that it started to speciate in all these other places, found these new niches, all these other little things, and now we basically get another radiation, a species radiation.
Wow.
From this one individual. So when we're looking at like the family tree, multiple lines of the family tree as we know it today go extinct.
Yeah.
And they stop. But then this one line continues on and then repopulates and respeciates, and now you have multiple new species over the next several million years.
It's like Noah's Ark.
Exactly. Yeah, it kind of is.
We are all descendants of the blue ash.
We are all from the
5
blue
million
ash.
years. Yeah.
Yeah. So then when you look
Crazy.
back through like the old fossils of all these other like conifers or something, you're like, wow, there's been like thousands of species of conifers at one point in time, and then multiple lines have just gone completely extinct, but then some of them have like expanded out and started these whole new things. And you can see that with conifers easily because we have so few left and we have fossil evidence of so many. But then with this, it's like if speciation with the limber pine is happening in front of our eyes, speciation with all these other conifers that have been like fully and 100% separated from each other, then you have like this allopatric and sympatric speciation, all these things. In this case, this ash is like ready, it's on the precipice of like this species radiation,
Wow.
you know, which is a really fun thing to think about in the future. Like, this could be the one saving grace. The ones that could not take it died.
Yeah.
So only the one that is tough enough and actually has that resistance will start again, which means every other species that comes from the blue ash in the next 5 million years will also have the relationship to this insect that they will survive. So now you have this balance that happens over evolutionary time.
But by that time, Casey, there will be a new insect.
Right?
And I also feel like, is this not extremely common? I feel like humans are the product of the same kind of trajectory. No?
Oh, absolutely, yeah.
And in 5 million years, all homos will be descendants of sapien.
Yes, yeah.
And well, it's slightly different because the blue ash didn't kill out all of the other ashes.
Well, as far as we know, I mean, according to your theory, maybe it did.
It could have been yeah. But we killed all of the other homos.
Exactly. Yeah.
Come on, don't take me out of context here.
Oh my God, this tree podcast just said he killed all the other homos.
And he was happy about it.
He was so happy. He was giddy. Man, I did not know you to be so homophobic. Wow.
Don't do that to me. I've gone 5 years without getting canceled.
Yeah. Al, I wish you could have kept it up. You bigot.
But it is that must be a kind of a trait of evolution.
Oh, absolutely, yeah. And we historically call those in a one population bottlenecks.
Now we're talking.
Exactly, where you have this one tiny little glimmer that breaks through where everything else died, and then everything else radiates from whatever was left.
And then it just happens again and again and again.
One of the big things is whenever there is a mass extinction, that kind of thing happens, where you only have this small subsect of whatever survived. Those things then repopulate the world at large. Birds are a great example. All the other dinosaurs died. Birds survived.
Yeah.
And now birds have taken over the entire planet.
Taken over the skies.
Yes, with literally thousands and thousands of species. Yet they all went back to one common ancestor.
That's fucking crazy.
Isn't that wild?
Casey, by that logic, would it not make sense that life is just getting like better and better at living over time?
You know,
but then there will be new threats and new dangers and new extinctions.
Yeah.
But maybe like not in context with the big picture. I feel like maybe just things are getting more and more fit.
Well, I think yes.
They're the descendants of the ones who survived.
Yeah, but the one thing is, like, if you take I don't know, all of, humanity. Let's say we have one person who's really huge and strong. They can lift up a lot of weight. This is Alex Crowson. And then there is this fleet-footed, lithe Casey who can run really fast but is just not worth a damn lifting anything. All of the Alex Crowsons die because of some disease.
I don't like this.
So now, by that logic, because I'm the one that survived, that makes me the most fit only in regard to that disease. So I have the gene that makes me better at that disease, but that makes me completely unable, and all of my descendants unable to lift anything heavy.
Yeah.
So we are more fit in one regard, but less fit in another.
Interesting.
regard.
Okay.
So it's really the population as a whole, or like all of the different collections of populations are really what I think make everything a little bit more resilient.
Yeah.
Where if we only had the green ash, and that one was really good at every situation across the entire eastern United States. It's one of the most common ash trees we have. That one crushes it everywhere. One insect comes through and it's shit. It just completely dies.
Yeah.
But then You have another population of a different species who's like, actually, I'm pretty good at this, and then survives, but maybe they can't go quite as far north because blue ash isn't quite as hardy as green ash. You know what I mean?
So they might be, in the long run, less successful than the white ash or the green ash.
Yeah, so they're not going to do a whole lot. It might be that this becomes just one species that hangs out exactly where it's native, and it doesn't actually expand out. It doesn't do this big adaptive radiation kind of thing. It's just like, yeah, I'm just good right here, and I'm just going to stay. And it is not going to find its way out. It'll be outcompeted by maples or oaks or something else.
Very interesting.
Yeah, so I think in one regard, you're exactly right. But I think in another regard, it's still a loss of all that other genetic diversity that would be good and better in other ways.
And it's all relative, like there'll be in 5 million years, there will be a super virus that still kills everything.
Exactly.
Even though they may be more fit than we are now, but that super virus is more fit than our viruses.
Yeah, exactly. So it's this constant arms race, right?
Yeah.
And this is the thing that I think is so fabulous about trees, and also why we need to keep biodiversity at the highest level we can.
Yes.
Is that it might be that if we go through and cut down all these trees or destroy a forest or you name it, we're actually destroying the genetic kind of pool that we can choose from and help things adapt over time, because trees and plants have huge genomes, like massive, so that if something happens, they can turn on and turn off different things and access these like really ancient kind of genes that they've not used in years, but when they get the right amount of stress, triggers it, they turn it on, all of a sudden our green ash, our white ash, our black ash are like, oh, geez, okay, I gotta start making this thing. I've been getting attacked for the last 20 years, But 20 years in consideration of how long these species have existed, that's like 45 million years for when they first started.
Yeah.
So 20 years is nothing. It's a blink of an eye.
Totally.
It's less than a blink of an eye. It's nothing entirely.
Wow.
So you gotta still think, okay, maybe there's still time for the other colors of ashes to develop these things and kind of be like, whoa, shake out of this fog that they're in, and then respond, and then be able to put up their own defenses.
Evolution is interesting like that. Not that I fucking know anything about evolution besides what we've talked about on this podcast.
Yeah, that's basically everything. We've covered it all.
Okay,
there's no more questions.
I have a master's degree now. But evolution is interesting like that because it happens all the time. Yeah. But also over a very, very, very long time. Like it's hard to like if you look at it, it disappears. You know?
Exactly.
You have to like look at it in your periphery and there's 45 million years.
Oh, yeah. Yeah. Exactly. I love that description. That's exactly what it is.
Cool.
And we humans have been here for so long and we've learned about it that we're like, oh, well, we get it now. But like our so long is at the most 400,000 years. And like, if you do the math, like the length of time that a Douglas fir lives, the generation of a forest out here in the Pacific Northwest, even in 400,000 years, where it's 10,000 individual human generations, for that tree, it might be like maybe 100.
Damn.
So you're like, ooh, the timelines here are insane.
Yeah, it really makes me think that we all all living things kind of experience time differently. Like,
totally differently.
They live in slow motion.
Yeah. I mean, imagine an octopus. They live for 1 year, yet they have a wild amount of intelligence that we can see. So that mom will live her entire life, grow up from adolescence to full adulthood to I just had babies to I'm going to protect them until I literally withered away to nothing.
In a year.
In 1 year. Yet that is still like a lifetime.
Yeah, to that is its entire lifetime.
Exactly.
In the same way that 80 or something years to us is an entire lifetime.
Yes. Yeah.
So it makes me wonder, like, do they experience that amount of time in the same amount of time that we experience our lifetime?
Yeah, and then think about like a tortoise that lives for 300 years, or a blue whale that lives for 300 years, like all these other things that live as one body in one lifetime.
Yeah.
It's all, like you said, it's all relative. Wow. And we're not even going to talk about trees because we're going to talk about that later.
We're not even going to talk about trees. We're going to talk about taking a break.
Yeah, we got to go.
I gotta piss and shit. I'm just kidding.
That's horrifying.
We're gonna take a little quick break. When we get back, we're gonna give a rating to the blue ash, see if it deserves a medal for its valor against in its war against the ash borer, or the opposite of that, jail time for letting a dark agent into its borders.
Yeah, and letting it just go ham on all of its friends.
We got to do so after a quick break. We'll be right back with Completely Arbitrary. Welcome back. Casey, it's time to review the blue ash.
Let's do it.
Here's
I'm
how
ready.
it works. We're going to give some final thoughts on this tree and then give it a rating of 0 to 10 golden cones of honor. Casey, as our resident expert, we'll begin with you.
So, generally speaking, I like a tree that's got something going on. I like it. I like when it's interesting. You know this. I like when it's got a superlative very often. And I also like the trees that do, I think you put it, you like a tree that fights back a little bit.
Yeah.
This tree, though it's unique, it doesn't really fight back. It's not like a tree that it's like, I am actively going to fight and do something kind of on the front foot. It's more like, man, I'm just better adapted, so I'm still alive.
Totally.
So I dig that. I think I like that it's blue. I think blue is my favorite color. And, it gets a thing there.
It's not blue, Casey.
I know, but its name is blue.
Okay, fair.
And that counts for me.
Yeah.
So the ash itself is fine. I like that it has rectangular twigs.
Yeah.
Makes it really easy to identify. And I love that trick, that one like gotcha for every tree.
Yes.
Feels so good.
Yes.
So it really doesn't jump out at me in an intense way. But I like that it's blue. I like that it has this thing. And I love that it is the one species where we're like looking around with complete destruction, kind of shell-shocked, watching all these trees die in like no time. Yet there's one tree that's just sitting there being like, fine.
Yeah.
I like that. It kind of,
cool.
Makes my day. So I think I'm going to give it 8.0.
Damn.
A very high score, but also like,
Okay, you like the story more than the tree itself.
I think so. Yeah. Exactly. It's exactly it.
Okay, Casey, 8.0 is very,
So I'm going to choose 8.0.
very fine score.
Yeah.
Okay, Casey, here are my thoughts on the blue ash.
Okay.
For fun, I'm going to say that it is a traitor defector and invited the emerald ash borer.
Yeah.
It's the red wedding, right?
It invited it into its house.
Yes.
Here,
The
monster.
The blue ash is the river guys.
The blue wedding. You're calling the blue ash the phrase?
Yes, the phrase. Thank you.
That hurts. That hurts bad.
I think they're a bit of a phrase situation.
Wow.
And as everybody dies around them, they're just sipping on their tea, on their mead, and letting it happen because they paid a price for this.
I am. This is a lot for me to take.
Sorry. When you were describing the blue ash kind of just shrugging off all these insects, I was thinking about that trope in fantasy where like there's a battle going on and then there's like a giant or a troll or something.
Yeah.
And there's like a wide shot and it shows like people shooting arrows at it and they're just bouncing off its skin.
Yeah.
And it's like, what's going on? Oh, there's a battle. But it doesn't know that it's being attacked.
Stepping on people. Yeah.
That's kind of how I feel about it, just shooing away the ash borer.
That sounds about right. I'm with that. I like that.
And I respect that, but I can't respect this tree. I think it should have gone down with the other ashes.
You think it should have gone down with the other ashes? You're kidding me. No.
So I will be giving the blue ash.
Don't.
Also, the one cool thing about it as a tree for me, besides all that stuff, is that it has rectangular limbs.
Yeah, which is
that's
great.
pretty cool.
That's awesome.
By the way, does it grow out of that once they get big enough?
Yes, yeah. Once
Okay.
it gets big enough, it just looks like normal circular kind of cylindrical stems.
Sure. Well, I'm sorry to do this. I feel like you're going to be mad at me.
I'm already mad at you.
But I'm giving the blue ash a 2.3.
What?
Yeah.
A 2.3? Yep. You're just trying to cause controversy.
The wrong ash died.
I can't believe this. What other ash would you even want to live? It's the coolest of all the ashes.
Ketchum from Pokemon.
Oh, jeez. Okay, this is done. Let's move on.
Wow.
I'm upset with you, but your cones are your own, and that's fine.
Yeah, thank you for acknowledging that.
Fine.
My cones are my own. That doesn't mean you can't have an opinion about it.
Exactly. I know exactly that's what that means.
It means you deserve your opinion. I deserve mine. Mm-hmm. Anyway, now that the air's been sucked out of the room by my 2.3,
I'm going to drink this water.
Casey, it's time for our completely arbitrary AMA. Let's do a quick subscriber check.
How many we got here today?
If you missed it before the end of the year, we begged and pleaded for you to join the Supercast.
Yeah, and man, did you guys show up.
Seriously, we got 803 right now.
You guys are the friggin' best.
803 people subscribe to us as you would like a Netflix.
Yeah.
Or like a Bark Box.
So everyone's getting their cone.
And you know, Casey, the thing that makes me really grateful for it is how much I hate subscription-based services.
Yeah.
And like these people are willing to overlook how awful this system is.
Yeah.
To support you and I.
It feels really good.
That's fucking awesome.
That's a community is what it is.
And they get cool. That's true, Casey. And they get cool things in return.
Yeah.
So if you want to become a premium member of this podcast, join the Legion.
Bring yourself
to arbitrarypod.supercast.com. Casey, this week we got one from Kishi.
Okay.
Kishi says, hi, y'all.
Hey, Kishi.
Hi, Kishi. Hi, y'all. For the past few weeks, you've been talking about trees interacting with each other through VOCs.
Yes.
Volatile organic compounds.
That's right.
And other chemical signals. In the past, you've also talked a lot about adaptations trees have developed against predation. Mm-hmm. Oh, predation. That's new. That's a new word to me. But it's
really? Predation would be the act of predating, of being a predator.
So this is against predation.
Exactly.
Okay.
So essentially, they release these compounds to tell other things, or to communicate, or to make it less palatable, so that other insects don't eat them.
I'm pretty interested in trees that use toxins as a defense mechanism.
Yeah.
And was wondering if you knew of any that use this adaptation to defend against other trees.
Ooh.
Do you guys have a favorite gnarly tree adaptation to protect against predation and competition? Also, I love when people ask questions and they end it with a nice little thing.
Oh, yeah? Okay, what we got?
Also, just wanted to say I love the show so much and cannot express the extent to which it has impacted me personally.
Whoa, Kishi, thank you.
Can't wait to see what comes next for y'all. Rooting for you both. Casey, what?
This is a good question.
Yeah. Because it took me 8 hours to read that paragraph. I'll just summarize. What is your favorite adaptation to protect trees use to protect against predators?
Man, okay, so this one's specifically against other trees.
Correct, but I was kind of opening it up.
Yeah, okay.
I was adapting the question.
Yes. Well, let's see. This is a good question because there's a lot of different things that kind of go on with that. But most of the time, the thing that happens like underground, most trees don't attack other trees in terms of like predator prey kind of thing.
Sure.
You know, even like the strangler fig or a parasite, it's not really attacking it to eat it. You know, it's like keeping it alive, taking what it can, or using its structure simply as a leg up kind of thing, right?
Right. It's not necessarily trying to kill it. It's like using it to survive.
Exactly. But I don't know of any tree that like actively goes out and eats another tree, you know, or even a plant that really does that. There is plenty of fungus that does that they'll go out and find one of these other species, or of course insects and animals.
Interesting.
But the very first thing that comes to my mind is like the allelopathy of the tree of heaven, for example, where it puts in chemicals into the soil that actively keeps things away from it.
Yeah.
But honestly, I think my favorite is going to be like not even close, but it's got to be like an ant.
I knew you were going to say this.
I love that ants like fight off other plants for their home plant.
Yeah.
And you got to think that like half the way they figure these things out is that they can smell what the chemicals of their plant is putting out kind of thing. Mm-hmm. Well, I don't know. So that's a really good question.
Yeah, that's a cool one. I always just think it's interesting that we talked about it earlier, but you nick a tree.
Yeah.
And it'll push some sap out.
Yeah.
And like the truest, purest application of that being like an insect.
Yes.
That lands and sticks its little fucking nose in there. And the tree's like, not today.
Not today. Blah.
And it throws up a bunch of sap all over the bug.
Yeah, it works out great.
Which then hardens and like traps the insect in this amber. Then later Jurassic Park finds it. You
Exactly.
know?
And then everyone's like, this is the coolest thing. This is a billion-year-old little bug.
But I just think that's so cool.
Yeah.
I love that trees do that. I just love
Yeah.
like defense mechanisms in general. Maybe it's
Right.
because I have so many of them myself.
Well, I think that if it, talking about the VOCs, I think that's probably one of my favorite things also is the fact that an insect can eat a leaf and then the tree identifies what insect it is by the saliva and then calls in that particular insect's predator.
That's fucking crazy.
That's insane.
Speaking
That's
of evolution,
crazy to know. Yeah.
Like what an incredible math equation.
Yeah.
Do you know what I mean?
Yeah.
Like,
How do you like figure all that out?
and like how long did that take to like do that?
Exactly. And develop. You
Yes.
know? Who knows?
Crazy.
Like the generations until all those trees are doing it. Like that means that the generation the individual that first gets it right survives and interbreeds with all of the other individuals to the point where that gene is now transferred throughout the entire population.
Yeah.
It's got to be millions upon millions of years.
Wild.
Crazy.
Very cool.
So what other things are there?
Well, so don't some trees grow kind of spikes or whatever the other ones are? Kind of
like junipers, right?
Yeah, based on like attack damage.
Exactly. Something eats them, and then the next leaves that they grow are sharp and poking.
Yeah,
kind of
yeah.
Thing. Yeah. Lots of plants do that to lots of different ways.
That's so cool.
Yeah. So, but it's not really like a VOC kind of compound, but
Yeah.
it is a reaction from the tree to make sure that it's not going to get eaten. You know.
Right.
But having the chemicals inside the leaves to make them taste bad or even be poisonous, I think that's also a cool thing. Zoe Schlanger's The Light Eaters talks about this with I think it's bagworms, which are like these moth. It's a species of caterpillar that lives in like a tent. It looks like a big spider web, but inside are just all these little funny little caterpillars. Alex hates this. Sorry. They like make this big tent around this, like the end of this twig, and then they eat all of the leaves inside of that tent.
I've seen this.
Yeah. And it's often on alder species or birches or something like that, a couple different species. But apparently there's been some cases where it has been like an entire forest kind of gets afflicted with these, and they end up eating all of the leaves, but then the next trees or the next leaves that get produced put in a whole bunch of intense compounds, and then the insects go over and eat those, but they can't leave. Like they created their little home, so then they end up dying because they're getting like really bad nutrition.
Wow.
So the tree over time changes the chemistry of its leaves to make it unpalatable to the point of killing the insects that are eating it.
Now, that's amazing,
Yeah.
but when will that just become an evolutionary trait? Like, how about we just put that shit in the new ones?
Yes,
You
right.
know?
It probably won't because of budget. Where if there's
Yes.
nothing there, the plant's like, it's actually way more beneficial for me to just grow up and get big and tall.
Okay.
And then get all the energy saved up to when I do need to use it, I'll sacrifice some of my leaves while I
Wow.
build up these new ones.
Okay.
And a lot of times these are well, it's not all the time, but many times it's deciduous trees. So the deciduous trees lose their leaves. They don't need to worry about making them big and tough. But the next year, or when they grow back new ones the next season, then they're like, oh, but these ones, I learned from last year, I'm already adjusted to this.
Cool.
And then now they're just like set forward. But they didn't waste any energy making those intense leaves before that.
Let's not pay a firefighter to sit in our house all day in case there's a fire.
Exactly.
Let's just call them when it happens.
Yeah, and
if it happens.
and we got so many houses that we can just let a few of them burn down while we go rebuild some others and make them fireproof.
Yeah.
Yeah, it's pretty much
Interesting.
the same idea.
Okay, resources. It all comes down to budget, right?
It all comes down to budget, and trees are smart enough to know when to use and when to save.
When to hold them and when to fold them.
Exactly. They are basically a Kenny Rogers song.
That's incredible. Well, thanks, Kishi, for your question.
Yeah, thanks so much. That's great.
And like I mentioned before, and I'll mention again, become a Treemium member, arbitrarypod.supercast.com, or you can go to arbitrarypod.com to check out our merch store, old episodes, show notes, etc.
That's right.
Casey,
Alex,
Clapp.
I need to tell you something that's been bothering me this whole time. I'm going to look it up.
Okay.
Map of the United States. There has been a state that I have not been able to identify, and I've been staring at it since I've looked up Fraxinus quadrangulata range map. And I'm like, oh, yeah, Missouri right there.
Okay, go ahead and
What is that state?
describe it to me where it is.
It is just below Missouri,
No.
just above Louisiana, just to the northeast, yet touching Texas, to the east of Oklahoma.
Is that not Kentucky?
No, Kentucky is above Tennessee. And the
Is that not
state,
Tennessee?
No, it's not Tennessee. The state, it touches the very border of Tennessee.
Well, what the fuck?
Exactly, which is why I'm looking this up, because I am so frustrated. I used to be able to do this all the time. You ready for this? It's freaking Arkansas.
Arkansas.
Oh my God. I have spent so much time in Arkansas. I am a fool.
Have you really?
Yes. Yeah. I've spent so much time in Arkansas.
Funny.
Just chilling up in northwest Arkansas, where one of my ex-girlfriend's families lives. So I'm just like, I'm sitting here and I was just racking my brain, and I almost started singing like the song, like all the states that are all in alphabetical order.
Yeah.
And if I did, I would have gone to Arkansas in no time. But I'm like, what state am I missing?
Well,
Man, I got to go to sleep.
As way of apology to our Arkansas listeners, use coupon code Arkansas for 10% off your next merch order.
Yeah, if you're not from Arkansas, don't use the code.
No, please.
We do not offend you.
Honor system. Well, thank you, everybody, for listening to this episode of Completely Arbortrary. We will be back next time with the next episode in our big countdown and our big 12 to the final days of our lives.
That's what?
See ya.
Alex, wait. Completely Arbortrary is hosted by Casey Clapp and Alex Crowson.
Our music is by Aves and the Mini Vandals, and our artwork is by Jillian Barthold.
To support the podcast and get rewards in return, become a Treemium member at arbitrarypod.supercast.com.
Thanks for listening.